Hi, so I'm going to talk to you about the arctan function because I love this function. So let's start with the usual tangent function, which is plotted over here in blue. So one thing to notice is that this fails the horizontal line test. So there's, for example, the horizontal line y equals 1, and it intersects the graph several times. But what you could do is restrict the domain of the function so that the horizontal line only crosses the graph once. So recall the vertical asymptotes of tangent are x equals, or two of the vertical asymptotes, I should say, are at x equals pi over 2 and x equals negative pi over 2. So I could have picked different choices. You could have picked 3 pi over 2 or negative 3 pi over 2. It's just a choice we make to pick pi over 2 and negative pi over 2 because they're, closest to 0. But anyway, so if you restrict the domain to just negative pi over 2 to pi over 2, then now this function passes the horizontal line test. So the horizontal line y equals 1 crosses the graph at only 1 point. So that means that you could take its inverse. Okay, so we don't need that horizontal line anymore. So to take the inverse, the graph is reflected across the line y equals x. So before I reflect the graph, I know that the vertical asymptotes become horizontal asymptotes. So it becomes y equals pi over 2 and y equals negative pi over 2. And then the graph becomes the arctan function, which is plotted there. So I'll get rid of those two, and now it looks like that. So it's vertical asymptotes negative pi over 2 and pi over 2. Anyway, so if you take the derivative, you get 1 over 1 plus x squared. And so note that the arctan function is always increasing, so its derivative is always positive. And the point where the slope is the steepest is at 0, 0, and that's where the function 1 over 1 plus x squared takes its largest value, where it's 1. So that's the derivative of the arctan function.